G 10.7 Area of a triangle. In lesson G 10.5 we learnt about the sine rule. In lesson G 10.6 we learnt about the cosine rule. These two rules allow us to calculate missing sides or angles in triangles, and in particular non-right angle triangles, by using trigonometry. In today's lesson we are going to continue to use trigonometry, but this time to calculate the area of a triangle, where we cannot simply use the formula area is equal to half base times perpendicular height. Before we can use this new formula, we need to be able to label our triangle correctly. This is the same labelling that we use for the sine rule and the cosine rule. The sides are labelled using the lowercase letters A, B and C. The angles are labelled using the capital letters A, B and C. We need to make sure that the side and the angle opposite each other have the same letter. For example, if I labelled this side lowercase a, then the angle opposite it must be labelled capital A. If I labelled this side lowercase b, then the angle opposite it must be labelled capital B. Finally, if I labelled this side lowercase c, then the angle opposite it must be labelled capital C. The formula to calculate the area of this triangle is area is equal to a half times A times B times sine C. So to calculate the area of the triangle, we need to know the length of two sides, side A and side B, and we need to know the size of the angle in between them, angle C. We also need to follow these steps. Step 1. Make sure your calculator is in the correct mode. This is something that we must do every time we use trigonometry. Step 2. Label the triangle. Start by labelling two sides that you are given, A and B, and then label the angle between these two sides, C. You can then label the remaining angles and side if you choose. You may not be given these values, but that is fine as you will not need them for this. We will look at an example where we are not given enough information, or when we are given too much information, shortly. Remember, you can label your triangle to suit what you need, even if it means changing the labels that have already been assigned to a triangle, or changing the labels partway through a question. Step 3. Write down the formula. And then finally, step 4. Substitute in the values that you know and solve to find the area. Remember to only round your answer at the very end of the question. Also remember your units. We're working out area this time. So units will be things like centimetres squared or metres squared. And as always, check that your answer seems reasonable. Let's have a look at the questions. The first thing we need to note is that diagrams are not drawn to scale. This just means that we cannot measure them. Question 1. Calculate the area of the triangle. Give your answer to 3 significant figures. So with this triangle we are given the length of two sides. We're given 13 centimetres and 8 centimetres, and we are given the angle in between these two sides, 59 degrees. So first of all, I'm going to check that my calculator is in degrees mode, which it is. Now I'm going to label the triangle. So I'm going to start by labeling the two sides, A and B. Now it doesn't matter which order these are in, so I'm going to choose A to be 13 centimetres and B to be 8 centimetres. So because these are sides, I'm using lowercase letters. Then I'm going to label the angle in between these two sides as angle C. Now this is a capital C because it's an angle. What I can do now is I can label the remaining angles and sides if I wish. I don't have this information, I don't need to use this information, but just for completeness, I'm going to label the angle opposite side A as capital A, the angle opposite side B as capital B, and the side opposite side C as, the side opposite angle C as lowercase c. So now I've labelled my triangle, I'm going to write down the formula. Area is equal to 1/2 AB sine C. I'm now going to substitute in the values that I know. So 1/2 multiplied by A, well lowercase a is 13 centimetres, multiplied by B, lowercase b is 8 centimetres, multiplied by sine, and then capital C, that's my angle, 59 degrees. And now I just need to put this into my calculator. So it might be worth you doing this at the same time as me to make sure that you get the same answer. With the 1/2, I can either use my fraction button or I can use 0.5. If you are using your fraction button, just make sure you use the arrow to make the cursor go to the side of the fraction, so that when you do times 13 times 8 times sine 59, that doesn't end up underneath the fraction as the denominator. So putting this into my calculator, I get a really long decimal number. I need to round it to 3 significant figures. So 44 point, and then that will be 6. So 44.6. My units are centimetres squared because my lengths are in centimetres and I'm working out the area. So centimetres squared, that has been rounded to 3 significant figures. And that seems like a reasonable answer to me, being in the area of the triangle. So there we have it, that is the area of my triangle, where I've got two sides, 13 centimetres and 8 centimetres, and an angle of 59 degrees in between. The area is 44.6 centimetres squared, rounded to 3 significant figures. So it's your turn now to have a go at some questions like these, where you are calculating the area of a triangle. In each case, you will be given enough information to be able to work out the area without having to do any additional calculations. When you are given too much information about a triangle, the labelling of your triangle is essential here. Make sure you have got two sides and the angle in between those two sides. Any additional values are not needed for these. Pause the video to copy the notes, to check your understanding and to try the questions from I'm giving it a try. Remember to mark your work and reflect on your confidence. Unpause the video when you are ready to try the next question. Question 2. Calculate the area of the triangle. Give your answer to 3 significant figures. So with this triangle, we are given the length of two sides, 15.4 centimetres and 19.9 centimetres, and we are told one of the angles is 27 degrees. However, this is not the angle in between the sides we are given, so this could cause a problem, as we don't yet have enough information to calculate the area. In order to work out the area, I need to have the length of two sides and the angle in between them. So for this question, I either need to work out the length of this side here, so that I've got two sides and then the angle of 27 degrees between them, or I need to work out the size of this angle here, so that I've got two sides and the angle in between them. Let's think about the methods that I can use for calculating missing angles and sides in non-right angle triangles. First of all, we need to remember that angles in a triangle add up to 180 degrees. Next, we also need to remember that we can always use the sine rule or the cosine rule. For this question, there is no method that will immediately get us either the missing side or the missing angle that will allow us to calculate the area, so we have to think a little bit more creatively. I am going to use the sine rule to calculate this angle here, and then I will be able to use angles in a triangle add up to 180 degrees to calculate this angle here. Then I will have enough information to calculate the area. So let's use the sine rule first of all. The angle I want to calculate initially is going to be labelled capital A, so the side opposite that is labelled lowercase a. The other side and opposite angle that we are given are labelled lowercase b for the side and capital B for the angle. That means that the remaining side and angle are labelled lowercase c and capital C respectively. So I'm calculating angle A, so the sine rule that I need to use is sine A over A is equal to sine B over B. We substitute in what we know, and we have sine A over A, which is 19.9, is equal to sine B, 27, over B, 15.4. Now we can solve to find A. Sine A is equal to sine 27 over 15.4 multiplied by 19.9. So A is equal to the inverse sine of that answer. So putting this into my calculator, remembering always to check that it's in the correct mode, I get that angle A is equal to, and again it's a long decimal, 35.9 ... degrees, because it's an angle. Now it's really important here, because this is not our final answer, we need to keep that that entire number in the calculator display. We're going to use the full number for A and not round it yet. And now what we can do is we can use this to calculate C, because we have got two angles in our triangle, and we know that angles in a triangle add up to 180 degrees. So we can find C by doing 180 degrees, take away 27 degrees, take away the answer that we have just got for A, and this is where I'm going to use my answer button on my calculator, so we keep the whole decimal for A, and that gives me C being 117.08 ... again a really long decimal that we need to keep all of those digits, and then that's degrees because that is an angle. And finally, now we have got enough information to calculate the area of the triangle. We have got the length of two sides and the size of the angle in between. At this point, it may be necessary to relabel your triangle. However, I have already got my two sides labelled A and B and the angle in between labelled as C, so they're labelled correctly. So I'm going to write down the formula for the area. Area is equal to half AB sine C, and I'm going to substitute in what I know and solve to find the area. So 1/2 multiplied by A, which is 19.9 centimetres, multiplied by side B, which is 15.4 centimetres, multiplied by sine, and then angle C. Now, because this was a long decimal and I want to keep all of that information, I don't want to round until the very end, I'm going to use my answer button again on my calculator. So 1/2 times 19.9 times 15.4 multiplied by sine of my answer. I get that the area of this triangle, rounded to 3 significant figures, is 136 centimetres squared. And only now can I round my answer. So the area of this triangle is 136 centimetres squared. I've got my units. I've rounded it only at the end, and I've rounded to 3 significant figures, and I think that my answer seems reasonable given the information in the question. So this one was a really tricky one. Initially, we didn't have enough information in order to calculate the area. So with questions like these, think about the tools that you can use. So we've got angles in a triangle add up to 180 degrees. Then we've also got the sine rule to calculate either a missing side or a missing angle. And we have also got the cosine rule to calculate either a missing side or a missing angle. A tip here would be to try to use the easiest method first. So if you can use the angles angles in a triangle add up to 180 degrees, then use that one, as that's much easier than using the sine rule or the cosine rule. Also remember properties of special triangles like isosceles and equilateral triangles as well. Once you have calculated the additional information you need, you will probably then end up with too much information. So select two sides and the angle in between to calculate the area. So it's your turn to have a go at some questions like these then. Pause the video to copy the notes, to check your understanding and to try the questions from I'm Building My Confidence. Remember to mark your work and reflect on your confidence. Unpause the video when you're ready to try the next question. Question 3. The area of the triangle is 716 millimeters squared. Calculate theta. Give your answer to 1 decimal place. So for this question, we are told the area of the triangle, and we need to work backwards to calculate the missing angle. Now looking at the information in our triangle, we have got the length of two sides, 45 millimeters and 32 millimeters, and we need to calculate the angle in between those two sides. My calculator is in the correct mode, so let's go straight ahead with labelling the triangle. So the two sides that we know. We need to label A and B. It doesn't matter which way round. So I'm going to label 45 millimeters as lowercase a and 32 millimeters as lowercase b. And the angle in between them, which is theta that we need to calculate, I'm going to label capital C. Just for completeness, I'm going to label the rest of the triangle. This angle is angle A, this angle is angle B, and this side is side C. Now I'm going to write down the formula. Area is equal to half AB sine C. Now I need to substitute in what I know. So this is where this method is going to be slightly different. We know that the area of the triangle is 716 millimeters squared. So I'm going to replace area with 716. Then we've got is equal to 1/2 multiplied by, now A I know is 45 millimeters, B I know is 32 millimeters, and C is theta. That is what we need to calculate. So I've now got that 716 is equal to 1/2 multiplied by 45 multiplied by 32 multiplied by sine theta. So now I have to solve to find theta. So the first thing I can do is divide both sides of my equation by all of 1/2 multiplied by 45 multiplied by 32. So this gives me that sine theta is equal to 716 over all of 1/2 times 45 times 32. So now to find theta, I just need to do the inverse of sine. So theta is equal to sine to the -1 of the answer to 716 all over 1/2 times 45 times 32. And this gives me that the angle theta is equal to, now I've got to round to one decimal place, so it's 84.0, and my units are degrees because I'm calculating an angle, and that's been rounded to one decimal place. So my triangle that had an area of 716 millimeters squared and two lengths given to me, 45 millimeters and 32 millimeters, I have worked out that the missing angle in between sides A and B is 84.0 degrees. And this seems like a reasonable answer. It's worth mentioning here that the units throughout this question were in millimeters, and then the area is of course in millimeters squared. So if I had to calculate a length in this triangle, then of course my units would have to be in millimeters as well. It is always worth taking a moment to check the units in the question first and make sure that they are all consistent. So it's your turn to have a go at some questions like these then. You will be given the area of triangles and you will need to work backwards. In some cases you will need to calculate missing lengths in a triangle, and in other cases you will need to calculate a missing angle. If you are calculating a missing angle, you must remember that you will have to use the inverse of sine. Pause the video to copy the notes, to check your understanding and to try the questions from I'm Ready for Anything. Remember to mark your work and reflect on your confidence.